In recent years, the shift toward renewable energy has been hailed as a pivotal solution to combat climate change and reduce our reliance on fossil fuels. However, this rapid expansion raises critical questions about its environmental implications. In this video, we'll explore the complex dynamics of the renewable energy boom, examining how it impacts land use, resource intensity, and local communities, while also addressing waste management challenges and infrastructure strains. Join us as we navigate the delicate balance between advancing green technology and protecting our planet. 1. The rise of renewable energy. The rise of renewable energy has been nothing short of meteoric. Countries around the globe are racing to harness the power of the sun, wind, and water, hoping to curb their reliance on fossil fuels. According to the International Energy Agency, renewables are expected to account for nearly 30% of the world's electricity by 2023. This push is driven by a mix of political pressure, public demand, and the undeniable need to combat climate change. Yet, with such rapid expansion, there are bound to be growing pains. As we transition, questions about the sustainability and environmental impact of renewable installations are increasingly coming to light. 2. Land use and habitat disruption. One of the primary concerns with renewable energy infrastructure is the vast amount of land it requires. Wind farms, for instance, need expansive tracts of land to operate efficiently. Similarly, solar farms need large, open spaces to generate significant power. This requirement often leads to the disruption of natural habitats. For example, solar farms in desert areas can disrupt the fragile ecosystems that exist there. The construction of renewable energy sites can lead to deforestation, displacement of wildlife, and loss of biodiversity. The impact on local flora and fauna is a significant downside that is often overlooked. 3. Resource intensity of renewable technologies. While renewable energy sources are cleaner in terms of emissions, the technology that harnesses them is anything but. The production of solar panels, wind turbines, and batteries requires a significant amount of raw materials. Rare earth metals, such as lithium and cobalt, are essential components. Mining these materials is resource-intensive and environmentally damaging. This creates a paradox where the quest for clean energy contributes to pollution and habitat destruction in mining regions. With the demand for these materials skyrocketing, the environmental toll could be severe. 4. Waste management challenges. Another often overlooked aspect of renewable energy is waste management. Solar panels, for instance, have a lifespan of about 25 to 30 years. After this period, they become e-waste, which is challenging to recycle. The disposal of these panels can lead to the release of toxic materials into the environment. Similarly, wind turbine blades are made of non-recyclable materials, posing significant disposal challenges. As the renewable energy sector grows, so does the mountain of waste it generates, raising concerns about its long-term sustainability. 5. Impact on local communities. The establishment of renewable energy sites can sometimes lead to conflicts with local communities. Land acquisition for wind and solar farms can lead to disputes with indigenous populations or local farmers. The noise pollution from wind turbines and the visual impact of large solar farms can also be contentious issues. While renewable energy promises benefits on a global scale, the localized negative impacts can be significant. This raises ethical questions about the balance between global environmental benefits and local harm. 6. Intermittency and infrastructure strain. Renewable energy sources, particularly wind and solar, are intermittent by nature. The sun doesn't always shine, and the wind doesn't always blow. This intermittency poses challenges for energy grids, which are designed for consistent power delivery. To compensate, energy systems need to integrate storage solutions or backup power, often from fossil fuels. This can lead to increased emissions and infrastructure strain, somewhat negating the environmental benefits of renewables. Balancing the grid with renewables remains a complex challenge. 7. The global supply chain. The renewable energy industry is global, with components often manufactured in one country and assembled in another. This global supply chain can lead to a significant carbon footprint. Transportation of materials and components contributes to greenhouse gas emissions, which offsets some of the environmental benefits of renewable energy. Moreover, the energy policies and environmental regulations of countries involved in the supply chain can vary widely, leading to inconsistent environmental standards. This inconsistency can exacerbate the environmental impact of renewable energy production. 8. Conclusion. A complex balance. As we navigate the renewable energy boom, it's crucial to acknowledge the complexities and challenges that accompany it. While renewables offer a path away from fossil fuels and their associated environmental harms, they are not without their own environmental costs. By understanding and addressing these issues, we can better ensure that the transition to renewable energy is genuinely sustainable and beneficial for both the planet and its inhabitants.